Dear students, let me welcome you all to today's session. Today we are going to learn and understand the basics of the topic titled Sequences and Series. The main points that I am going to cover today, we will be talking about arithmetic progression. We will be talking about geometric progression. I have written AP here. AP, it corresponds to arithmetic progression, and GP, it corresponds to geometric progression. So questions pertaining to AP and GP, that is what we will be covering today. Okay. So to start with, some of the basic concepts and formulae which you must be knowing before you are attempting the questions. That's what I am going to cover. So I request all of you to take down these points, whatever I am covering, all those quick formulae and all those concepts. Listen full and full, and towards the closure, you can share your questions and queries, which I shall address and answer. Okay. So to start with, let us first consider the basics of arithmetic progression. Okay. So we will consider all the basic concepts, formulae, everything in this discussion. Okay. So first we are starting with this arithmetic progression. See, progression, when I say, you can see it will be something like this. Okay. Suppose say I start with the number 3, then I am writing the number 7, then I am writing the number 11. Okay. Then I am writing the number 15. You can see it follows a logical and a mathematical pattern. Okay. It follows a logical or a mathematical pattern. You can say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You can see that it increases by 4 steps. Okay, 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, so on and so forth. Here you can see that the number, it shows an increase in the trend, right? It shows an increasing trend. It can happen the other way around also. Okay, maybe it can start with 15 minus 4, it is 11, minus 4, it is 7, minus 4, it is 3, 3 minus 4, it is minus 1, minus 1 minus 4, it is minus 5. You can see that it can even show a decrease in the trend. But still, it's fine. We consider it as a progression only because it follows a logical or it follows a mathematical pattern. Okay. So let us analyze the series that I have presented here. We can see here the number 3 I have written, right? We consider this 3 as the first term of this progression. The first term. Generally, the first term, it is represented using the letter A. Sometimes it is even presented as T1, term 1, the first term. So these are the notations that you should be familiar with. The first term, it is represented using the letter A, or it can also be represented as T1, term 1. So make a note of that part. I shall use a different color here. First term, it is represented using small letter A, or it can also be written as T1, term 1. Okay. Now, I want you to consider the difference between the second term and the first term. I am writing it as T2 minus T1. You can see T2 minus T1 in this case, it is 7 minus 3, which is equal to 4. Same way, if I am going to consider T4 minus T3. That is 15 minus 11. The fourth term minus the third term. 15 minus 11. That is also equal to 4 here. Suppose I am going to consider the difference between the third term and the second term as T3 minus T2 if I am considering 11 minus 7. That is also equal to 4. So we can see the difference between two consecutive terms in this way when I am considering. That difference is the same. Okay, so that difference I call it as the common difference. Okay, and arithmetic progression, it is associated with this common difference, which is represented using the small letter D. Okay, so if you know the first term, if you know the common difference, as this particular progression, it follows a mathematical pattern, you can predict what is going to be the 7th term, what is going to be the 12th term, what is going to be the 19th term. Any term in that order you will be able to predict. This formula you have to remember the expression to find the nth term of an arithmetic progression, Tn, nth term of an arithmetic progression, it is given by a plus n minus 1 times the common difference. For example, you consider the series I have presented here, 3, 7, 11, 15, etc., so on and so forth. Suppose I want to find out what is the 6th term of this given progression, T6. So what will you do? You will substitute the values here. Here the first term, you know, it is 3. The common difference here, you know, it is equal to 4. You are asked to find T6, that is the 6th term. So T6 will be A plus N. N value, you know, it is equal to 6 here. So 6 minus 1 times D. D, it is equal to 4. So you can say 3 plus 6 minus 1 is 5. 5 fours are 20. You can see that 3 plus 20, that is equal to 23. So the 6th term, it will be 23. Now, I want you to focus on this given progression here. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. Please note 15 plus 4, that is equal to 19. That is the 5th term here. Okay, 19 plus 4, 19, 20, 21, 22, 23. See, that 23 what I have written here, it is the 6th term. See, the first term, second term, third term, fourth term, fifth term, the 6th term. The 6th term, you can say it is coming as 23. But I didn't write all those 19 and then come to 23. Using this formula, I am able to find out the nth term of this given arithmetic progression. So you must remember the expression to find that nth term of this arithmetic progression, it is a plus n minus 1 times d. Make a note of this. Tn is equal to a plus n minus 1 into d. Okay. Now, in the same manner, from that formula, okay, so I shall just write it here. Okay, Tn, it is equal to a plus n minus 1 times the common difference. Let this be there. Now, in this arithmetic progression, let us consider, you know, the last term. Okay, you are putting an end, maybe you are considering some 15 terms over there. Okay, so you are aware of the last term and you know what is the first term. Okay, now you want to find out how many terms are there in this given progression that you are considering. Okay, so that number of terms in a progression is given by last term minus first term upon common difference plus 1. Tn minus T1 divided by D plus 1. Okay, for example, in the series, when I am considering 3, 7, 11, 15, okay, let me say it goes up to say 35. Let me put it in this way. I want to find out how many terms are there. Okay, so what I will do here, I assume the 35 is part of the series. Let me just check. Yeah, 35. Okay, so we can consider here 3, 7, 11, 15, etc. up to 35 I am considering. I want to find out how many terms are there in this progression. Okay, so what I will do here, as per what I am considering, 35 is the last term, 3 it is the first term. The common difference, it is equal to 4. So last term minus first term divided by the common difference plus 1. 35 minus 3, it is equal to 32. 32 upon 4 plus 1, which is 8 plus 1, 9. You can see that altogether in this given series, there are 9 terms. Okay, you want to check, you can check this. Okay, after 3, 7, 11, 15, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So see this 1, 2, 3, 4, 5, 6, 7, 8, 9. Altogether, there are 9 terms in this progression. Got it? So to find the number of terms in the progression, the formula that you have to remember is, I shall write it here once again. Number of terms, it is given by last term minus the first term divided by the common difference plus 1. Increment it by 1. Okay, so that expression you have to remember. Now in the same way, suppose I am considering the series like this 3, 7, 11, 15, etc. Okay, I consider say 43. Okay, so these are the numbers involved in this progression. Suppose I want to find out the sum of all the terms involved. I want to find the sum of all the terms in the above progression. Okay, in the above progression. Suppose I want to find out the sum of all the terms in the above progression. One method is you list all the terms and then add it. Fine. Another method is we have to find out how many terms are there in this given progression. Okay, so you can say that is last term minus first term upon common difference plus 1. 43 minus 3, it is 40 upon 4 plus 1, it is equal to 11. You can see that in this given progression, you can see that all together there are 11 terms. Okay, so now you want to find the sum to n terms, sum to 11 terms of this progression. Okay, 11 terms you are considering. So how to find that? For that, there is a formula n by 2 into 2a plus n minus 1 times the common difference. This is one formula, which you can remember. N by 2 times 2a plus n minus 1 into d. In the same way, there is another formula. Sum to n terms can also be calculated using another formula. Both you should remember. Sum to n terms, it will be n by 2 into last term plus first term. N by 2 into Tn plus T1. This can also be used to find sum to n terms of the progression. Okay, so these two formula also, as far as arithmetic progression it is concerned, you have to remember. So I shall list them here. Sum to n terms of an AP, it is n by 2 into 2a plus n minus 1 times the common difference. Also, sum to n terms is given by n by 2 into last term plus first term. Okay, so these basic formulae, 4 I have written here. Okay, if you are able to memorize it and keep it as a ready reckoner, a good majority of the questions from arithmetic progression can easily be handled. Okay, so kindly make a note of these 4 critical, crucial formulae as far as our arithmetic progression it is concerned. Okay, the expression to find the nth term, number of terms, sum to n terms, these two. Okay, make a note of this. Now, having completed the basic formulae, it is time for us to solve the questions here. Take a look at the first question here. It is given in an arithmetic progression. The first term is 19. The common difference is 4. You are asked to find the 18th term. So I shall list it here. The first term, it is 90. The common difference, it is equal to 4. You are asked to find the 18th term, T18. That's what you are asked to find. The expression to find the nth term of an AP is Tn is A plus n minus 1 times the common difference D. We can see substituting the values 19 plus number of terms 18 you are considering. Find the 18th term, right? So it is 18 minus 1 times the common difference, that is 4. So that will be nothing but 19 plus 17 times 4. And upon calculation, we can say this value, it will be coming here as 19 plus 17 times 4 when you do. You can say this value will come here as 87. So for our first question, 87 is our answer. Okay. Let us now go to the next question. The third term of an arithmetic progression is 55 and the 23rd term, it is 325. You are asked to find the 57th term. So let us deal with this question in a step-by-step manner. Okay. It is given the third term of this arithmetic progression is 55. So considering the first term, it is A, the common difference, it is D. The third term can be written as A plus 2D, right? A plus 2 times D. A plus 2D, the third term, it is given as 55. And then it is given that the 23rd term, it is 325. 23rd term means what? It is T23, which is A plus 22 times D, A plus n minus 1 into D. So I can thus see that the 23rd term, A plus 22 times D, that is given as 325. You are asked to find the 57th term. What is the expression for that 57th term? It is A plus 56 times D. That is the expression for that 57th term. So for finding that 57th term, we need to know what is A, we need to know what is the D, the common difference. Okay, so here we can see this is the first equation. We can consider that this is the second equation. If you simply perform, because we have to solve this, okay, with the help of A, with the help of D only, we will be able to get the answer. Okay, fine. So we can see now, just if you perform equation 2 minus equation 1, you can see that 22D minus 2D, 20D, that will be equal to 325 minus 55 it will come. Okay, and that is equal to 270. 20D, it is equal to 270. And from this, I can see that D, it is equal to 270 upon 20. 27 upon 2, it will come. Okay, I shall write it as 27 by 2 itself. That is the common difference here. Now, let me substitute the value for D, which I got it as 27 by 2 in the first equation. So the first equation now, it will become A plus 2 times 27 upon 2. That is equal to 55. Got it? So this gets me A plus 27, because here the 2 and the 2 will get cancelled off. So I can see that A plus 27, it is equal to 55. Okay. And that helps me to get the value for A. That is the first term. So I can see that here A, it will be 55 minus 27, and that is equal to 28 it will come. So as far as our question solving part it is concerned, I got the value for the common difference here as 27 upon 2. I got the first term here as 28. So with the help of these two, by substituting the value for A and D in that T57, A plus 56D, I can calculate that 57th term. So let us now find out what is that 57th term. I can see that now 28 plus 56 into 27 upon 2, that is going to be the 57th term, A plus n minus 1 into D. On calculation, I can see that this 28 plus 56 into 27 by 2, on calculation, I can say this will be coming here as 784. So as far as our question is concerned, the final answer, it is coming as 784. All right. So now you may take a screenshot of these steps here and please use it for your further reference. 784 is our answer. All right. Let's now consider the next question. Here you are asked to find the sum up to 60 terms of an arithmetic progression whose first term is given as 59 and the common difference it is minus 2. So the first term, it is equal to 59. The common difference, it is equal to minus 2. You are asked to find the sum up to 60 terms of this arithmetic progression. S60. That's what you are asked to find. Recall the formula. Sum to n terms of an arithmetic progression is given by n by 2 times 2a plus n minus 1 times the common difference. It comes like this. Okay. So we can see that here n it is equal to 60. Sum up to 60 terms. That's what it is said, right? So let's go for it. Sum up to 60 terms. It is given by 60 upon 2 times 2a, 2 into 59 plus n minus 1 into d. 60 minus 1, that is 59 times the common difference, it is minus 2. Okay. So now you can say this will be 30 into 2 into 59 minus 59 into 2, it will come. Because if you observe it closely, 60 minus 1 is 59, minus 2, bring that minus 2 over here, so it will be 59 into 2. So 2 into 59 minus 59 into 2. You know that this results in 0. So as far as this question it is concerned, the sum to 60 terms when you are considering, you can see that the value, it will be coming here as 0. That is my final answer. Okay. So that brings conclusion to the third question in this lot. Okay. Let's now consider the fourth question. Here you are asked to find the sum of the first 29 terms of an arithmetic progression whose fifth term is 5 by 4 and the 25th term it is 79 by 4. Okay. So let us consider the first term as A, the common difference as D. So as indicated in the question, the fifth term is 5 by 4. Fifth term means what? A plus 5 minus 1, that is 4D, that is equal to 5 by 4. Let this be the first equation. Okay. And it is given the 25th term is 79 upon 4. What is the expression for that 25th term? A plus 24 times D, that is the 25th term, that is equal to 79 upon 4. Okay. Now, we have got two equations here with two unknowns. So we are going to now consider subtracting equation 1 from equation 2. I am going to perform equation 2 minus 1. Okay, so you can see that when I do this 2 minus 1, A and A will get cancelled off. 24D minus 4D. You can see that 20 times D, that is equal to 79 upon 4 minus 5 upon 4, that is equal to 74 upon 4. We can see that 20 times D, it is equal to 74 upon 4. And upon cracking this, I can see the common difference here. It will be 74 upon 80, it will come. On simplification, it will be coming as 37 divided by 40, it will come. So that is the common difference that we are getting here. Substitute this D in equation 1 or in equation 2, you can get the value associated with the first term, that is A. Okay, so let me put it in the first equation. You can say first equation, it implies A plus 4 times common difference, 37 upon 40, that is equal to 5 upon 4. On solving this, I am now going to get the first term here. That first term, when I calculate and find it out, it will come here as minus 49 upon 20. Okay, the simplification part, I am asking you to consider it. So I have written up to this point. Okay, A plus 4 into 37 by 40. 4 and 40 will cancel off. It will come as 37 upon 10 is equal to 5 by 4. So A will be 5 by 4 minus 37 upon 10, it will come. Okay, that A value, it is 5 by 4 minus 37 upon 10, it will come. So for 4 and 10, 20, it is the LCM. So taking the LCM here as 20, it will now become 25 minus 37 into 2, which will be coming as 74, right? 30 into 2, 60, 74 it will come. 25 minus 74. So when I do that 25 minus 74, you can see that will be coming here as minus 49. That is how this is coming as minus 49 upon 20. Okay, so I just done the calculation for you. So I got the first term and I got the common difference as well. So with the help of these two, we can easily now find out the sum of the first 29 terms of this progression. You are asked to find what is that S29. That will be n by 2 into 2a plus n minus 1 times the common difference. We can see in this case it will come here as 29 upon 2 into 2a, 2 times minus 49 by 20, 2a plus n minus 1 times d. N is 29. 29 minus 1 is 28 times the common difference. It is 37 upon 40. Okay, so this is the calculation that you should be doing. Please observe it closely. N by 2, 29 by 2, 2 into minus 49 by 20, 2a plus n minus 1. 29 minus 1 is 28. 28 times 37 upon 40, it will come. So upon calculating this by simplification and calculating it, this will come here as 609 divided by 2. And as far as this question it is concerned, 609 by 2, that is going to be our final answer. Okay, we're asked to find the sum of the first 29 terms of this AP, which will come as 609 divided by 2. So we have considered 4 questions. Now, I shall complete the 5th question and then listen to your questions and queries, if any. Okay, so let's go to the 5th question now. Here, it is given if the 5th term of an arithmetic progression is 110, what is the sum of the first 9 terms? Okay, so let us first write the expression for that 5th term. 5th term means what? It is a plus 4 times the common difference. This is given as 110. What are you asked to find? You're asked to find what is the sum of the first 9 terms. Okay, so please note the sum of the first 9 terms is 9 by 2 into 2a plus 9 minus 1, that is 8 times d. And we can see that here, this is as good as 9 by 2 times from this 2a plus 8d. Listen carefully. From this 2a plus 8d, you can take 2, the common factor, right? So it is becoming now 2 times a plus 4d, it will come. Okay, so we can see that here a plus 4d, it is 110. Okay, so you can see that here this 2 and this 2 will get cancelled off. So now it will be 9 times a plus 4d, which is 110. And thus I am getting the answer here as 990. Okay, so as far as our fifth question it is concerned, the fifth term is 110. And you can see that the sum of the first 9 terms, it is coming as 990. Okay, now there is another interesting observation here which we can make out. Suppose there are 9 terms. Okay, I am considering T1, T2, T3, T4, T5, T6, T7, T8, T9. Please listen carefully. There's a small theory which I am trying to tell you. See, these 9 terms, if they are in arithmetic progression, listen, these 9 terms that I have presented here, if they are in arithmetic progression, then please note the arithmetic mean, it is nothing but the middle term. Okay, the middle observation. Here, as you are having 9 terms, 9 plus 1 upon 2, that is the fifth term, it is going to be the arithmetic mean. You got my point? The fifth term, that 110, it is going to be the arithmetic mean of all these 9 terms. All these 9 terms. Is this point clear to you? Because if you are having 9 terms, the middle observation, it is nothing but 9 plus 1, 10, 10 by 2. This T5, you can consider that this is that middle observation. Why I say that this is the middle observation? Because to the left side of T5, there are 4. The right side of T5 also, there are 4, right? 4 terms. So this is located exactly in the middle. And this guy will be the arithmetic mean of these 9 observations. Okay, so what is the sum of observations? The sum of observation is nothing but arithmetic mean into number of observations. Arithmetic mean, it is 110. Number of observations, it is 9. So that will also fetch you the result here as 990. Okay, so this result also you should be aware of. You can definitely solve the question using the formulae. But this result, if the numbers are in arithmetic progression, that middle observation itself will be the arithmetic mean of those set of observations. If you have that logic, you may be able to save some time later when you are practicing more and more questions. All right. Students, now let us consider the next question. Here it is given the sum of the first 5 terms of an arithmetic progression is equal to the sum of the first 6 terms of the arithmetic progression. Now the question is, what is the sum of the first 11 terms? Okay, so let us convert what all things that are mentioned here. Let us convert it into the equation part. Okay, the sum of the first 5 terms of an arithmetic progression. Assuming the first term to be A, assuming the common difference to be D, I can write n by 2, the sum of the first 5 terms, right? N by 2 into 2a plus 4d. Okay, n by 2 into 2a plus n minus 1 into d. The sum of the first 5 terms of this arithmetic progression. They say that this is equal to what? The sum of the first 6 terms of this arithmetic progression. So I can say that will be 6 by 2 times 2a plus n minus 1 into d, that is 5d, it will come. Okay, so now we can see that here this 2 and this 2 can be cancelled. Let me expand this 5 into 2a, 5 into 4d, 6 into 2a, 6 into 5d. Okay, so we can see that here 10a plus 20 times d, it is equal to 12a plus 30 times d, it will come. Got it? Now just doing the shuffling work, I'm taking that 10a to the other side, taking this 30d to the other side. I can see that 12a minus 10a, that is equal to 2a. Observe it closely. This is equal to 2a. That will be nothing but 20d minus 30d, that is equal to minus 10 times d. Or from this I can see that a, it is equal to minus 5 times d. Let this relationship between a and d be here. We will be using this for solving our questions. Okay. You can also see something interesting here. If I say a is equal to minus 5d, can I not see that here this can be rewritten as a plus 5d is equal to 0? Can I not say that then the sixth term, it is equal to 0? Yes or no? The sixth term, it is equal to 0, right? So this is going to help me to answer the question further very easily. You are asked to find the sum of the first 11 terms. Okay. By observation, I can say that if you are dealing with 11 terms which are in AP, okay, consider 11 terms which are in AP. If you consider, I can see that the sixth term, that is 11 plus 1 by 2. The sixth term, it is going to be the arithmetic mean. And that arithmetic mean, it is equal to 0. You can see that is happening here. The sixth term is 0. Did you get the point? The sum of the first 11 terms is what they are asking you to find. So those 11 terms are in arithmetic progression. 11 terms in arithmetic progression means 11 plus 1, 12, 12 by 2. The sixth term is going to be the arithmetic mean. That sixth term, arithmetic mean, it is equal to 0. What is arithmetic mean? Arithmetic mean is sum of all the terms divided by number of terms, right? So sum of all those 11 terms will be what? Sum of those 11 terms will be what? That will be equal to 0. Since arithmetic mean is 0, therefore, I can consider that the sum of the first 11 terms, that also will be equal to 0. Because arithmetic mean is sum of the 11 terms divided by 11. That is equal to 0. So sum of 11 terms will be equal to 0. Okay, if you didn't follow what I just said, in the conventional way also I can prove it. I can see that A, it is equal to minus 5D. Sum of the first 11 terms, it is 11 by 2 into 2A plus n minus 1 into D. 11 minus 1, that is 10 times D, it will come. You can see that 11 by 2 into, instead of A, I can put it as minus 5D. So 2A will be 2 into minus 5D. That is nothing but minus 10 times D plus 10 times D. You can see that here it is 11 by 2 into 0. Here also I am getting the answer as 0. Okay, but rather than doing this much of stunt and circus and all, the moment I realize that A is equal to minus 5D, I can see that the sixth term is 0. That is the arithmetic mean of these first 11 terms that is under consideration. That arithmetic mean itself is 0, which means the sum of the first 11 terms, it has to be 0. That way you can do the reasoning and say the final answer, it is equal to 0. Okay, so make a note of this. So that brings conclusion to our question number 6. Let us now consider the next question here. Here it is given the sum of 3 terms in arithmetic progression is 21. And the product of the extreme terms, that is among the 3, the product of the first term and the third term, the product of the extreme terms, it is 33. You are asked to find those 3 terms. Now, please note, whenever you are considering an input like sum of 3 terms in arithmetic progression is 21, like that if it is given, you can assume the 3 terms as, assume the 3 terms as A is the middle one, A plus D. Here you go for A minus D. Okay, so A minus D, A plus D. You assume these 3 terms like this. Okay, A minus D, A plus D. Now we are processing that first input that is given here. The sum of the 3 terms in arithmetic progression is given as 21. That is A minus D plus A plus D. You can see that minus D and plus D will get cancelled off. I will see that 3A is coming as 21, and that gets me the value for A as 7. Got it? So let that value A is equal to 7. Now please observe the product of the extreme terms is given as 33. Which are the extreme terms? The extreme terms, when they say, they correspond to this A minus D and A plus D. Their product, it is given as 33. So if I am going to rewrite it, I can see that A minus D into A plus D, this product, it is coming as 33. That is A square minus D square. That is equal to 33. Please note A is 7. So A square, you know, it is 49 minus D square is coming as 33. This gets me D square. It is equal to 49 minus 33, you know, that is equal to 16. So D, I will get it as plus or minus 4. It actually doesn't matter if it is plus 4 or if it is minus 4. It doesn't matter. Still, you will be able to get the 3 terms. Let me take the positive value here. Let me say that A is equal to 7. Let me say that D, it is equal to 4. I can consider the first term as A minus D. That is 7 minus 4, 7. 7 plus 4. I can consider that these are the 3 terms. You are asked to find what are those terms, the 3 terms. Okay. So you can see that 7 minus 4, that is 3. You have the 7 here. 7 plus 4, you have that 11 here. So the 3 terms are 3, 7 and 11. You can see all the conditions are satisfied. Sum of the 3 terms, 3 plus 7, 10. 10 plus 11, it is equal to 21. See, the product of the extreme terms, 3 into 11, that is equal to 33. It is also seen satisfied. So the 3 terms are 3, 7 and 11. Make a note of this. Okay. So that is bringing a conclusion to that 7th question. Let's consider the next question here. There are 2 sequences, 8, 11, 14, 17, etc. It goes up to 107. 9, 13, 17, 21, etc. It goes up to 129. So for these 2 sequences, consider these 2 sequences, you are asked to find the number of terms which are common to both these sequences. So if you observe some more closely, you can see that 17 is that first term which is common to these two sequences. Please observe, there is no 13 here, there is no 9 here. 17 is that, I should say, the opening batsman, I should say. The first term which is common to both these sequences, that is 17. Okay, so I am writing that 17 here. Please note the common difference as far as the first sequence it is concerned. You can see that it is equal to 3. 8 plus 3 is 11, plus 3 is 14, plus 3 is 17. Like that it goes. The common difference here, it is equal to 3. In the same way, let us consider the second sequence 9 plus 4 is 13, plus 4 is 17, plus 4 is 21. So the common difference, it is equal to 4. Now, I have identified, listen carefully, I have identified 17 here as the first term which is common to both these sequences. So, if I am going to write, listen carefully, if I am going to write a new sequence here, that sequence consists of these common terms. 17 I have identified. Like that, the common terms associated with this sequence as well as this sequence. If I'm going to list them, I can see that for that sequence, what I'm going to write, the sequence that consists of the common terms associated with the first as well as the second sequence presented there. So that new sequence, it will be having a common difference of 3 into 4, that is equal to 12. It will be like that only. So the next term, which is going to be common to these two sequences, that will be 7 plus 12. From where did I get the 12? 3 into 4. Okay, so I have identified the first common term here, that is 17. This 17 plus 12, that is going to be the next term which is going to be common to both these sequences. What is 17 plus 12? That is equal to 29. Got it? So 29 will be the next term which is common to both these sequences. You want to check? You can check. Okay, you can say 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 comes. Look at this 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. See, 29 is common in the first as well as in the second sequence. Okay. What about the next term? 29 plus 12. That is equal to 41, right? 29, 39, 40, 41. So on and so forth. Now you are asked to find the number of terms that are common to both these sequences. So till what extent? You can see that this guy ends at 107 here. Please be aware of this. Okay, this guy ends at 107. So till 107, that number, who all are common here? Okay, that I can identify. So I can consider here the first term is 70. The common difference here, it is equal to 12. So I need to satisfy the condition A plus n minus 1 times the common difference, it should be less than or equal to 107. It can be up to 107, which can be common to both these terms. Okay. But beyond that, it is not possible because the cap, the end, it is at 107. So A plus n minus 1 times the common difference 12, it should be less than or equal to 107. Okay, so let me simplify it. 17 plus 12n minus 12, it should be less than or equal to 107. Got it? So going in this logic, I can thus see that 17 minus 12, it is equal to 5 plus 12n should be less than or equal to 107. I can see that here that n value, it should be seen as less than or equal to how much? 8.5 you will get. make a note of this, that n value, you will get it here as less than or equal to 8.5. So I can see that I can't have an 8.5 term, right? That's not possible. So I can thus see that here there will be 8 terms which are common to both these sequences. Okay, so like this it goes. I can see that it can support up to 8 terms till this 107. 107 is anyway not part of both these sequences. Sorry, 107 I can say it's not part of both these sequences. It is only part of the first sequence. Okay, so I can see there are altogether 8 terms in common. Okay, I guess this is clear to you. The final answer for this question, I will say 8 terms in common. Okay, so please make a note of this. Number of terms in common, it is equal to 8, or 8 terms are there in common. In this way, when you are considering. Okay. Now let's move on to the next question. The next question, we are going to consider, it is all based on geometric progression. So before that, let me just check with you all whether you have got any doubts or anything. Okay. So dear students, now let us consider geometric progression. Okay. GP. Here also, in geometric progression, you can see that there will be some logical pattern, a mathematical pattern in which the numbers, they progress. Okay. So let's try to analyze a geometric progression here. Okay. So I'm starting with 3. That's the first term. Okay. 3. 3 twos are 6. 6 twos are 12. 12 twos are 24. 24 twos are 48. 48 twos are 96. So on and so forth. So if you observe, what you see here is a geometric progression. Why geometric progression? Because after 3, I'm multiplying it with 2. 3 twos are 6. 6 twos are 12. 12 twos are 24. Into 2, 48. Into 2, 96. So on and so forth. Okay. So there is a logical pattern here. You have to consider that here, the first term, make a note of it. The first term in geometric progression also, the first term, it is represented using the small letter a, or sometimes it is even represented as T1, the first term. Here, if you observe the ratio of, say, the second term to the first term, the ratio of the fourth term to the third term, the ratio of the seventh term to the sixth term, all these values, this ratio T2 by T1 or T4 by T3 or T7 by T6, in general, Tn upon Tn minus 1 that you are considering, it will be the same. That ratio will be the same. So that is why, as far as geometric progression it is concerned, we have something called as a common ratio. Okay, because like arithmetic progression, how it has got common difference, as far as geometric progression it is concerned, we have something called as common ratio. Okay, so please make a note of this point, common ratio. AP has got common difference, GP will have common ratio. So I shall write it here, the common ratio. And it is represented using the letter R. It is nothing but nth term upon n minus 1th term. Okay, something like the 10th term upon the 9th term. Like that we can consider. That is the common ratio. Now, just like how we considered the expression to find the nth term of an AP, as far as a GP, geometric progression, it is concerned, the expression to find the nth term, Tn, it is A into R raised to n minus 1. Okay, R is the entire R, it is raised to n minus 1. So the nth term is given by a into r power n minus 1. That n minus 1 is part of that exponent side. Okay. So T is equal to a into r power n minus 1. Okay. So this is one thing which you have to keep in mind. Now, let us consider the sum to n terms of a geometric progression. It is given by a into r raised to n minus 1 divided by r minus 1. Okay, please note here it is r raised to n that is decremented by 1. It's not r raised to n minus 1. Like what you see here, this is r raised to n minus 1. It's not in this way you have to interpret it. It is r raised to n that is decremented by 1 upon r minus 1. That is the expression to find sum to n terms of a geometric progression. But this you will apply when r it is greater than 1. The common ratio it is greater than 1. Okay, there is one more formula. Sn is a into 1 minus r power n whole divided by 1 minus r. This you will use when the r value is less than 1. Please make a note of this. Now, there is one more concept that is nothing but sum to infinity of a GP. Sum to infinity of a GP is given by a by 1 minus r. And please be aware, mod r, it should be less than 1. This is the criteria. Okay. So these are the main formulae as far as geometric progression is concerned that you must know. Nth term, sum to n terms, there are two situations there. Okay, depending upon the value for r. And also the sum to infinity, which is a by 1 minus r. So these four you must remember and by heart. And with the help of or with the knowledge of these, you will be able to solve questions further. Okay. So now it's time for us to do the questions from our material. So look at this question here. It is given in a geometric progression, the first term is 9 and the common ratio is 3. You are asked to find what is the seventh term. So the first term is 9. The common ratio, it is equal to 3. You are asked to find what is that seventh term. Okay, so the expression to find the nth term of a geometric progression is a into r raised to n minus 1. So we can see that here a it is 9 into 3 power n minus 1, 7 minus 1. Okay, because seventh term n is equal to 7. So 3 power 7 minus 1. So you can see this is 9 into 3 power 7 minus 1 is 6. So this is as good as, see, 9 is nothing but 3 square into 3 power 6. And this entire result, you can say it is 3 power 8. This is going to be my answer. If you remember what is the 3 power 8, you can express that as your final choice. You can see here 3 power 8, it is coming as 6561. I have done the calculation already, so that's how I'm able to share those numbers with you. It is 6561. So that is the seventh term in this given progression. 6561, it is my final answer. Okay, so we have just completed the 9th question. Let us now go to the 10th question in this lot. In a geometric progression, the first term is 3 and the common ratio is 4. You are asked to find the sum of the first 7 terms. So please note the first term it is 3. The common ratio it is given as 4. Number of terms considered it is 7. You are asked to find the sum of the first 7 terms. Remember, sum to n terms of a GP, it is given by a into r raised to n minus 1 divided by r minus 1. Okay, don't forget this. So, substituting the values, it will be 3 times r raised to n, decrement it by 1 by r minus 1, that is 4 minus 1. I can see that 4 minus 1 is 3, that is there in the numerator, also in the denominator. So I can cancel it off. So my answer now, it is 4 power 7 minus 1. Okay, you will know that 4 is nothing but 2 square, right? So it is 2 square, the whole power 7 minus 1. It is 2 power 14 minus 1, because 2 power 2, the whole raised to 7. 2 square, the whole raised to 7 is 2 power 14. 2 power 14 minus 1. And you can calculate 2 power 14. 2 power 14 is 16384. Minus 1, my answer will come as 16383. This is my final answer as far as our question it is concerned. Okay. Depending upon how the options are given, you can find out. Sometimes they might have given 4 raised to 7 minus 1. Sometimes they might have given 2 power 14 minus 1. Sometimes they would have given the correct number itself. So depending upon how the options are presented, accordingly, you can select your choice. Okay. So we have completed 10 questions altogether. So any queries you can ask. Students, please consider this question. In a geometric progression, the first term is 13 and the last term is 9477. The sum of all the terms is given as 14,209. You are asked to find what is the common ratio. Unfortunately, options are not given. If options are given, you can very well try with reverse substitution and get things done. But here options are not given. So let us consider the first term, it is 13. Okay. Let us consider that there are n terms associated with this progression. It is given the last term, it is 9477. Got it? So the last term, let me say it is that nth term. It is given by a into r raised to n minus 1. This is given as 9477. Okay. So I know the value for a, it is 13. 13 times r power n minus 1. You can see this is coming here as 9477. So upon further simplification, I can see that r power n minus 1, it is equal to 9477 divided by 13, which I have calculated. 9477 upon 13 when I do, I can say this result will come here as 9477 divided by 13 when I do, I can say this will come here as 729. The moment I see 729 and r power n minus 1, I can consider 3 power 7 minus 1. That is 3 power 6. What is 3 power 6? 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243, 243 3s are 729. Correct, no? So, 3 power 6, that is 3 power 7 minus 1, that is equal to 729, I know. Got the point? 3 power 6, it is 729, I know. Also, I can consider that 9 power 3, it is also 729. That is 9 power 4 minus 1. 9 power 4 minus 1. That is also 729. So these two things are running in my mind the moment I saw this 729. But which is what, I don't know. So for that, I am going to seek the second input here. The sum of all the terms, n terms associated, it is given as 14209. Sum to n terms is given by a into r power n minus 1 by r minus 1. Substituting the values here, you know, a it is equal to 30. 13 times r power n minus 1 divided by r minus 1. I can see that is coming here as 14209. It is given the sum of all the terms is 14209. So this gets me the result. Therefore, r power n decremented by 1 by r decremented by 1. This is nothing but 14209 by 13. 14209 by 13 when I do, I will get the result as 1093. Okay. So I got another lead here. So I have to select that appropriate value for that r and that n in such a way that it will satisfy this guy also. Okay, so here on closer observation, I can see that r is equal to 3 and n it is equal to 7. It will actually work in both the instances. Okay, you want to check, you can do that. R is equal to 7, n is equal to, sorry, R is equal to 3, n is equal to 7. It is going to work in both these instances. The first instance where it is coming as 729 and also this instance 1093. You want to check, you can do. R, it is 3. 3 power 7 minus 1 divided by 3 minus 1. When you do it, I can say it will work properly. I just checked it. Okay, 3 power 7, you know, it is 2187. Okay, minus 1, which is 2186 upon 3 minus 1 is 2. So 2186 divided by 2 when you do, you can say this will come here as 1093. It beautifully satisfies the condition that R is 3 and N is 7. So it all happens because I am somewhat comfortable with powers of numbers and all. So just by going in this manner, you are asked to find what is the common ratio. What is our answer? The common ratio, I know it is 3. Even we have gone to the next level, we have found the number of terms under consideration, you know, it is equal to 7. Okay, so as far as this particular question it is concerned, my final answer that I should submit, it is equal to 3 because they were asking about the common ratio. Okay, that ratio R value, I got it as 3. That is my answer. Okay. So I think this is clear to you. We have just completed question number 11. Okay. Let us now consider the next question here. It's a very interesting question. In an infinite geometric progression, every term is 9 times the sum of all the terms that follow. If the sum of the first and the second terms is 22, find the terms of the geometric progression. That is the question. So first thing what I should do is I have to present an infinite geometric progression. Okay, let the first term be A. The next term will be AR square, AR power 3, okay, AR power 4, so on and so forth. You can see that the first term is 9 times the sum of AR square. Okay, please note the first term is 9 times the sum of all the terms that follow. So 9 times AR plus AR square plus AR cube plus AR power 4 plus etc. It proceeds up to infinity. So this gets me the value 9 times sum to infinity. Here when you are considering, you can take AR as the first term. Okay, the first term is AR. The common ratio is R. So A by 1 minus R. Here it will be AR by 1 minus R it will come. You got it? So we can thus see that A, the first term, it is 9 times sum of all the other terms that follow. it is a infinite geometric progression. So we can consider it's the first term by 1 minus r, a by 1 minus r. So we can see that here in this case, this a and this a will get cancelled off. So that will get me the result r by 1 minus r. It is coming here as 1 upon 9. Please observe this a and this a goes off. If it goes off, it doesn't mean that the value is 0. Okay. So you can see that 1 is equal to 9 times r by 1 minus r. Or I can see that r by 1 minus r is equal to 1 by 9. You take this 9 to the other side, it will become 1 by 9. Okay. So how do we decide between 1 minus r or r minus 1? As far as sum to infinity of a geometric progression is concerned, the formula is always a by 1 minus r. There is no a by r minus 1. Okay, that is there only in the case where there are n terms associated with the geometric progression. It's not an infinite geometric progression. Okay, there you have something like Sn is equal to a into r power n minus 1 by r minus 1 and that 1 minus r. The other way around it can happen. But that is not a infinite geometric progression. But here it is given the series, it is an infinite geometric progression. Okay, that's why we go by this ar by 1 minus r. So we can cancel that a and a here. R by 1 minus r is equal to 1 by 9. Do the cross multiplication. I can see that 9r, it is equal to 1 minus r. I just did the cross multiplication. Okay. So that gets me taking this minus r to the left hand side. It will become 10r is equal to 1. And that gets me the common ratio here. It is equal to 1 upon 10. So I got a breakthrough here. R it is equal to 1 upon 10. But a got cancelled. You saw that? So I want to now find what is that a as well. But it is easy for you to find, okay? Because you can see that here, the sum of the first and the second terms, it is equal to 22, right? So we can see that here, as indicated in the question, every term, it is equal to 9 times the sum of the terms that follow. So if you observe the second term, AR, it will be 9 times AR square plus AR cube plus etc. It goes like that up to infinity. So you can say AR is 9 times AR square by 1 minus R. Got it? Fine. Now I know the value for here also that A goes off. Okay. Fine. Okay. No problem. Don't worry. We can see that now the sum of the first and the second term is given as 22. So A plus AR, it is given as 22. Okay. There is no need to consider the one what I just did. A plus AR, it is equal to 22. They gave you this input, right? So I can say A is a common factor. I can take it out. A into 1 plus R, that is equal to 22. R, I know it is 1 by 10. So I can say A into 1 plus 1 by 10. That is equal to 22. Upon simplification, A into 10 plus 1 upon 10. That is equal to 22. 10 plus 1, it is 11. 11, it will go in 22 2 times. So that gets me the value for A. That is the first term. It is equal to 20. Okay, so I got the first term as 20. I got the common ratio value here as 1 by 10. Now, it is easy for me to write that arithmetic progression because you are asked to find all those terms in that arithmetic progression. The arithmetic progression, I have considered that it is AR square, like that it goes, so on and so forth. So the first term, it is 20. Second term is AR, 20 into 1 by 10, it is 2. 2 into 1 by 10, it is 1 by 5. 1 by 5 into 1 by 10, which is 1 by 50, so on and so forth. Okay, it proceeds up to infinity. So they were asking you to write that arithmetic progression. find the terms of, sorry, write that geometric progression. What I meant is geometric progression. They were asked to write that geometric progression. You can see when I am writing it, it is geometric progression up to infinity. Okay. Accidentally, if I've said arithmetic progression, kindly correct it as geometric progression. Okay. All I meant was GP only. Accidentally, I meant to set a AP. Sorry for that. You can see the terms of that geometric progression, it will be 20 into 1 by 10, 2 into 1 by 10, that is 1 by 5, into 1 by 10, that is 1 by 50, so on and so forth. So these are the terms associated with that GP. Okay. So that brings conclusion to question number 12. Let us go to the next question now. Take a look at this question, the next one. It is given in a geometric progression, the sixth term is 5. You can see that as far as this geometric progression is concerned, first term being A, common ratio being R, the sixth term, okay, that is A into R power 5, this is given as 5. Let this be here. Okay. Now the question is, what is the product of the first 11 terms? So the first term will be A, the second term is AR, the third term is AR square, fourth term is AR cube, fifth term is AR4. Like that, I am taking the product. The 11th term, it is AR power 10. They are asking you to find the product of these first 11 terms, which means they are asking you to find what is A into AR square into AR cube into AR power 4 into etc. AR power 10. So you can see this product when you take, it is nothing but A into A into A into A into A into etc. 11 times you are doing, 11 terms you are considering. So it will be A power 11 into, when you are considering that R, it will be R to the power of 1 plus 2 plus 3 plus etc. up to 10. The rules of indices, x raised to A into x raised to B is equal to x raised to A plus B. So that rule is what I just applied here. So you can say R into R square into R cube into R power 4 etc. When I say this is as good as R raised to 1 plus 2 plus 3 etc. up to 10. So this will result in A power 11 into R power 1, 2, 3 etc. up to 10. The sum of first 10 natural numbers, it is equal to 55. So it comes as A power 11 into R power 55. So this can be now rewritten as A into R power 5, the whole raised to 11. Okay, A raised to 11 into R power 55 can be rewritten as A into R power 5, the whole raised to 11. But you very well know that A into R power 5, that is equal to 5. So what is going to be my answer? It is 5 to the power of 11. Got it? And that brings conclusion to this particular question. Okay. Now, there is another easy question here. I think probably we can consider that question as well. Look at this. In a geometric progression with even number of terms, the ratio of the sum of the odd numbered terms to the sum of the even numbered terms is 2:7. You are asked to find the R. So the first term is A, the second term is AR, the third term is AR square, the fourth term it is AR cube, the fifth term it is AR power 4, the sixth term it is AR power 5, the next term it is AR power 6, we have AR power 7, so on and so forth. Okay, so they are telling you in this geometric progression with even number of terms, the ratio of the sum of the odd numbered terms. That is, this is the first term, the third term, the fifth term, the seventh term, so on and so forth. This total up to n terms upon the sum of the even numbered terms. That is the second term, the fourth term, the sixth term, the eighth term, etc. This ratio, please note this ratio of sum of the odd numbered terms to the sum of the even numbered terms. This ratio is given as 2 upon 7. Okay. So if you look at this, you can say that this A, it is common in the numerator, and also you can say it is common in the denominator. That A can be removed. So this results in 1 plus r square plus r power 4 plus r power 6, etc. up to n terms divided by r plus r cube plus r raised to 5 plus, etc. It goes like that. But there is one thing interesting here. From here in the denominator, just to see if I am going to take r common factor out, just imagine here r is common everywhere. No, I take that r out, then what will happen? It results in 1 plus r square plus r power 4 plus r power 6, etc. It goes. Okay, just if you take that r, this question now becomes very easy. You can see that this numerator and this denominator, this can get cancelled off. So that results in 1 by r, it is becoming equal to 2 by 7. Got it? So if 1 by r is 2 by 7, it is easy for you to find the value for r. What will be r? R is nothing but 7 by 2. You are asked to find what is the value for r. I am getting the value for r here as 7 upon 2. Okay. So that brings conclusion to question, the 14th question in the lot. Okay. Fine. When I was just observing, we can see that it is sir, so that even number of terms in Q we did not use. No, we considered, I didn't get what that query is. We can see that here altogether, these are all odd and these are all even. In this case, A, I cancelled it off, and then I took that R out. It's up to n terms only. So this goes off and this goes off. 1 by R is coming as 2 by 7, R is 7 by 2. That's all. Okay. Let's consider one more question maybe. Okay, it's very easy one, that's why. Let's go for this also. I shall take up the queries towards the end. Okay. Let's consider this question. Sum of three numbers in geometric progression, it is given as 14. The product is given as 64. You are asked to find the numbers. So let the numbers in GP, let it be A by R, A, AR. Okay. Let the numbers which are in geometric progression, let it be A by R, A, AR. Okay. So these three numbers, when you are considering the product, if you take, you can see that the product is nothing but A by R into A into AR. R will get cancelled off. I can see that A cube, it is coming as 64. That gets me A, it is equal to 4. So I got one number here, it is equal to 4. Okay. Further, it is given the sum of these three numbers which are in geometric progression, the three numbers, the sum is given as 14. That is A by R plus A plus AR. This is given as 14. I know A, it is equal to 4 because 4 cube is 64, right? So I can see that 4 into, I can take 4 the common factor out. 1 by R plus 1 plus R. When I take it, I can say this total will come as 14. Got it? So from this, take this 4 to the right hand side. I can thus see that 1 by R plus 1 plus r, this will come as 14 upon 4, which is equal to 7 upon 2. Got it? Now I can take this 1 over here. I can take it to the right hand side. So that fetches r plus 1 by r. It is equal to 7 by 2 minus 1. 7 by 2 is 3.5 minus 1 is 2.5, which I can write it as 5 by 2. So a little bit of close observation you make, I can see that r, it will come here as 2. Because 5 by 2, it is, 2.5. 2 plus half. That is what 5 by 2 it is. So if you put r as 2, 2 plus 1 by 2, if you are having that real aptitude, you will be able to easily find out r it is equal to 2. Else you can find a quadratic equation, r square plus 1 is equal to 5 by 2 r. Like that it will come, sit and solve and get the value for r. But that is not needed. Okay, just a simplification will fetch you r is equal to 2. So now you got the first term is 4. The common ratio value, it is equal to 2. I have assumed the 3 terms as a by r, a, ar. So I can consider this will be 4 by 2, 4, 4 into 2. Like that it will come. So what are the terms? 2, 4, 8. You can consider these are the 3 terms under geometric progression under consideration. So 2, 4, 8, that is my answer. You can see, validate the results. Sum when you take, you can say 8 plus 4 is 12. 12 plus 2, it is 14. The sum of the 3 numbers in geometric progression, you can say the sum is 14. The product is 64. See this 2 into 4, 8. 8 8s are 64. That is also satisfied. The 3 numbers involved are 2, 4, 8. Okay. So with this, we will conclude our today's lecture on our sequences and series. In the subsequent interaction, we will solve more questions from this topic.